All right, so let's take a look at 7.2 homework question number 4. So we're given some summary statistics for the randomly selected weights of newborn girls. We're asked to use a confidence level of 95% to complete parts A through D below. All right, so what I did was I just wrote down these values for reference on a piece of paper. N is equal to 36, so the degrees of freedom will be equal to 35 since the degrees of freedom is just n minus 1. We have x bar, we have s, and we have a confidence level of 95%. We're asked to find the t value that splits the middle 95% from the outside 5%. So here's what we'll do. Let's go to StatCrunch. And then, so we're going to go to stat, we'll go to calculators, and then we'll go to T, right? So instead of using a Z, we're using a T. Now it's important to note that as the number of degrees of freedom gets larger and larger, the T value will approach the Z value. But, you know, typically we'll always use the T distribution as opposed to the Z when we're doing the mean problems. Because if you have a very large sample size, the T distribution value and the Z value will end up being the same. Anyway, so our degrees of freedom, which I wrote down, are 35. And then we're looking for the area between, we're looking for those T values, and we want our area to be 95%. So we're going to enter 0.95 in here, and then we'll hit compute. We'll get a value of 2.03. So that answers our first question right here. So we'll go ahead and input that. Now, find the margin of error. So there's a couple different ways to find the margin of error, but what we'll do is this. We're going to go back to StatCrunch, and I'm going to go ahead and close this. This time we're going to go to stat, then we're going to go to T-stats. Then we'll go to one sample, and then we'll go to with summary, because we're not using data, we're using a summary. So we'll enter the sample mean, which was 3211.1. We'll enter the sample standard deviation, which is 689.4, 689.4. We're going to click on the confidence interval, and this is a 95% confidence level. The sample size is 36, and then we hit compute. So while here we have everything we need to answer any questions about this particular confidence interval. Our lower limits are 2977.8 to 3444.4 if we round to one decimal. Our sample mean, which is our point estimate, is 3211.1. And then how do we find the margin of error? So the one way we could do this is very simple, is we know that from the lower limit to the middle is one margin of error, and from the middle to the upper limit is another margin of error. So what I'm going to go ahead and do is I'm going to go ahead and I'm going to write down the middle is 3211.1, and then I'm going to subtract the lower limit of 2977.8. All right, so let's go back to here. So this is the lower limit, and that's the middle. So the distance from the middle to either of the endpoints is one margin of error. So if I take my calculator and I just go ahead and type in 3211.1 minus 2977.8. That will give us a margin of error of 233.3. So the margin of error is equal to 233.3. So I'll go back to the problem. I'll input 233.3. Hopefully we don't encounter a rounding error. All right. And then the confidence interval, I mean, we calculated that in the same area. Our confidence interval is going to be from 2977.8 to 3444.4. So we can enter those values, 2977.8, up to 3444.4. And that is our confidence interval. And then write a brief statement that interprets a confidence interval. So a confidence interval, it gives us a range of, estimates of what the true mean would be, right? And the level of confidence is how confident we are that the true mean will fall in this range. So, so one has 95% confidence that the sample mean weight of newborn girls is equal to the population mean weight. No, let's see. Yeah, okay, here it is. One has 95% confidence that the interval from the lower bound to the upper bound contains the true value of the population mean. That's the one. It's the true value of the population mean is within that interval, that confidence interval that we found, and we're 95% confident that that is the case. And that concludes this lesson.